The broadcast is now starting. All attendees are in listen-only mode.
Good morning. My name is Mark Abraham.
Morning.
I'm with A&M Industrial. I want to thank you for joining us this morning. This morning we're going to talk about coming back from COVID the Loctite way as part of A&M University. A&M University was founded last year with a trade show and multiple in-person technical sessions from a variety of industry experts. This year we're having virtual A&M University, and today we're excited to have Henkel Loctite join us and make a presentation. October is Breast Cancer Awareness Month, so A&M is trying to do its part to raise awareness and support breast cancer research. One way is through these pink PPE products. A portion of the proceeds will be donated to the American Cancer Society. These items are available on our website or by contacting anyone at A&M. During the current pandemic, we also have a variety of products for people to keep their employees safe and their production running. So a variety of things from PPE, disinfecting, sanitizing, and more. We have a catalog of those items online, or again, you can reach out to your A&M person. So if there's any way we can help with those items, we're happy to do that as well. A&M has a broad portfolio of products. As you can see from the picture here of our buyer's guide, all the categories on the left, you can see we have everything from cutting tools and abrasives, safety and personal protection products, pipe, valves and fittings, fluid handling and hose assemblies, tape and packaging, janitorial and cleaning supplies, and today we'll be talking about a category we call mill supplies, as you can see, where Henkel Loctite is part of that portfolio. So I hope you're on for this class today. In a minute, I'm going to hand it off to Josh and his team, who will introduce themselves and get right to the point. I will be watching the question. You can type in questions during Josh's talk, and I'll do my best to field those questions, and he'll also take questions at the end. So with that, give me a minute, and Josh is on. Josh, while I give you control, maybe you can introduce your team, and we can get started from there.
Sure. Thank you very much, Mark. I'm going to set this up here. But my name is Josh. Josh Decker. I'm the MRO rep here in New Jersey and New York area. And let me just make sure I'm getting this back. Do you see my screen yet?
We can see your screen. We can see your desktop, not the PowerPoint.
Okay. Gotta get it switched over. Give me 1 second. Where is it? Oh no. It's not giving me the option. Here we go. Show screen 2. There we go. All right.
There you go.
Good. You got the presentation now?
Yes.
Perfect. All right. Sorry about that. All right. Thank you, Mark, and thanks everybody for taking the time to join us today on the call. And especially thank you to A&M. Been great partners with us. Scott and the team over there, you guys have been awesome. So again, we appreciate the time today, and we're going to jump right into this. So we're going to talk about coming back from COVID. So whether you've been up and running, shorthanded, or you're just getting back after COVID, everything we go over here should be able to help you with preventative maintenance and making sure you guys are ready to go. So again, my name is Josh Decker. I'll be presenting along with Matt Barber, my counterpart, Rich Yanavich, and Dave Schnell, and we'll go over the areas that we each cover in just a moment. So just a quick agenda and overlook of what we're going to go over today. I'm going to do my best to keep it quick and to the point, make the most use and keep it effective. Don't want to waste anybody's time. We appreciate you guys taking the time today. So we're going to try to streamline it as much as possible and get you the most information out of it. So agenda for today, we're going to go over the reps and the areas that we all cover. Product overview, thread lockers, thread sealing, gasketing, retainer are our core 4 modules. And we'll touch on Magnacrete as well for concrete repair. We'll also go over documented cost savings. And we have some resources and additional training available, so we'll go over those as well. And we'll leave some time for questions at the end. So going over the areas in which everybody covers, I am, again, the MRO rep for New Jersey and Metro New York, including Long Island. My contact information is here, but we'll get you that through an email afterwards. Matt Barber is my counterpart. He is the OEM rep, so he handles anything more on the manufacturing side in that same area. Rich Yanavich, who's also going to be presenting today, is the MRO rep for Rhode Island, Maine, New Hampshire, Massachusetts, New York, and Connecticut. And Dave Schnell, who handles New York, parts of New York and Vermont. And he is an MRO and OEM rep for those areas. So as we talk about COVID-19, obviously this has been something very different for all of us that we're all working through together. So a couple of recommendations that we have as we are coming back or starting back up are machine inspections, just making sure everything is running and ready to run, proper alignment and torque for especially nuts and bolts, employee stress management, which is something that we may need to focus on a little bit more now, more than ever, as everybody has different situations going on with COVID. Equipment management, looking at a summary and having reports available just to document everything that you've got going on in the plant. And planning for the future. As we know, safety is the #1 concern, but again, a lot of what we do is focus on preventative maintenance, right? Reactive maintenance when we're shutting down. It's costly, so our goal is to help you guys plan for it and prevent it. So let's talk about Loctite products. Almost all of our products are made of anaerobic chemistry. So let's talk about anaerobic chemistry. What is anaerobic chemistry? Well, we know that aerobic, you think of moving, working out, getting the blood flowing. When we talk about getting the blood flowing, we're talking about, that's from oxygen getting into the blood and moving the blood, pumping the blood through the bodies. So we talk about aerobic being or pertaining to or caused by the presence of oxygen. So anaerobic is talking more about the absence of that air or the lack of oxygen. So like I said, all of our products, or almost all of our products, cure in the absence of air and the presence of active metal ions. So when you think about active metal ions, you're talking about brass, copper, like you see the Statue of Liberty. And when you think about active metals, you can think of things that rust, or in the Statue of Liberty's case, right, copper changes it from its original color. So bronze, iron, steel, all other types of active metals, right? So when we think of inactive metals, we're talking about stainless steel, something that has a coating on it to prevent it from rusting, or pure aluminum, titanium, and nickel. So again, our products cure in the absence of air, that's #1, and the presence of active metal ions, which is why we would use them on nuts and bolts. So we're gonna go over some typical chronic failures that you guys probably see in your facilities. And the #1 is fastener loosening, right? If there's no Loctite or there's no adhesive on there, in many cases with traditional methods, you'll get fasteners loosening. Some other ones you'll see keyways wallowing out, spun bearings on shafts, tape fouled valves, hydraulic leaks, air leaks, gasket leaks. All of these leaks are stuff that you guys are probably seen or have encountered at some point in your facilities. And a lot of those come with, downtime or costly or high cost, big costs. And what we want to do is kind of help you guys prevent those, right? Because nobody wants that downtime can be very costly. So we're going to take a closer look. So I'm going to open this up and let you guys use that chat function now. So when you think of a nut and a bolt, what do you think the amount of metal to metal contact in a form of a percentage? What do you think that metal to contact is between a thread and a bolt, in between the threads? I'm going to open it up to the chat now. Any guesses?
I don't see anything yet.
Okay. Anybody want to take a stab, shot in the dark? 10%, 80%,
Okay,
100%?
so I have one guess. Somebody put in 50%.
50%. Okay, great guess. Any others?
Oh, I see another one. Another one is 35%.
35%. Great guess. So it's typically what we'll see is, I gotta get back on that. presentation here. 15 to 30%. So 35 great gas, 50% another great gas. But the reason is you can't have 100% metal to metal contact, because if you did, you wouldn't be able to tighten the nut on around the bolt, right? If it's 100%, there's no room for turning. So you need to have some airspace in there to tighten it. But also having that airspace can be a problem, right? Because then you allow for loosening later. So great guesses. Appreciate the feedback, guys. So the goal is to have 100%, but like we talked about, you can't have 100% from the get-go because you won't be able to get the nut onto the bolt. But our goal here is to fill that gap, right? Fill the gap, unitize the assembly so that once it's on and it's in the position you want it to stay, it doesn't back off, it doesn't loosen. So with that being said, I'm going to turn it over to Rich, and Rich Yanavich is going to go through some mechanical fastening methods and talk about some of our thread lockers. Rich, can you hear me?
Thanks, Josh. Yes, thanks, Josh.
Sure, and just let me know if you need me to pause any of the videos or go to the next slide, just let me know.
Sure. Before you start this video though, Josh, I just want the audience to know that the audios on these videos are not going to come through. So what I'm going to do is I'm just going to talk through the videos and explain what you're actually seeing. So with that, Josh,
thanks, Rick.
You could start. And as Josh was mentioning earlier, you know, it's that air gap that creates all the problems, right? So there's a lot of traditional mechanical ways of creating clamp load, double nut, spring washer, nylon insert, so on and so forth. All of these and many more are used to help create and hopefully maintain that clamp load. But the one core problem that they really all have is they're all susceptible to vibrational loosening, you know, shock, thermal expansion, and contraction. All for the simple reason is they don't fill in that airspace in between the male and the female threads. And until you do fill in that airspace, you're just susceptible to vibration. You're susceptible to shock and thermal expansion and contraction that allows the flanks of the male and the female threads to actually rub against one another. We call that side sliding. So what you're seeing now is a transverse shock device. And what that is, that's just simulating vibration, right? And all those typical traditional mechanical ways of locking a nut and a bolt together will put on that transverse shock, and you can see how quickly they lose their clamp load. And the last one in that red line there, that's Loctite thread locker on there. And the reason why it was able to perform so well is that it filled in all that airspace in between the threads. And until you do that, you're just susceptible. Does this mean that traditional locking devices do not work all the time? No, it does not mean that. It just means that eventually, if the external influences in terms of shock and vibration and thermal expansion and contraction are greater than the friction alone that those traditional locking devices create, then they will fail over time, okay? And another added benefit of using just a few drops of thread locker is you fill in all that airspace. Now you prevent not only side sliding, but you also prevent moisture and corrosion from happening as well. You go to the next one. So we have two fasteners, one with the use of thread locker, the other one no thread locker, both torqued down to the same specs. And now when they put these cranes under vibration, what I really want you to notice is what happens to the nut on the assembly that does not have the thread locker. And this is what vibration does to every fastener. The one thing to remember, nothing vibrates tighter. Okay, vibration is going to loosen up the bolt. Why? Because there's a lot of airspace in there. Okay, there's a room for them to slide. And if you want to prevent that sliding and get more reliability with your clamp load, you really have to fill in that airspace. So as you can see here, I'm going to do a torque demo. You notice that I'm practicing proper social distancing in my garage here. So the question I have for the audience, what I'm going to do now is I'm going to take a 3/8 fastener and I'm going to torque it down to 100 inch-pounds. And the question I have for the audience, and you can type it into the chat box, is if I torque it down to 100 inch-pounds, how much torque would it take in order to loosen that? Will it take 100 inch-pounds? Will it take more than 100 inch-pounds? Or would it even take less than 100 inch-pounds? You guys
Rich,
just want to take
clarify,
a moment.
This is without any Loctite on there, correct?
Yeah, there's no thread locker on this. This is just torquing down the fastener to 100 inch-pounds.
Okay, so I don't see any guesses yet. Let's see, I'm waiting.
What I'm trying to show you there, that their little red dial was at 100. Now I'm resetting it and I'm gonna break it. And it's about 70, 75. It's gonna be about 70% of the on torque. So if you torque something down to, 100 inch-pounds or 70 inch-pounds or 50 inch-pounds, in order to break that loose, it only takes about 70% of that on torque to come off. And that's because of all that airspace that you have in between the threads. Not all of the torque that you use to create that clamp load is going to the clamp load. Only 15% of it is. You're using a lot of it in friction underneath the head of the bolt as well as on the threads. So that's something to really keep in mind, that on a fastener that doesn't have any thread locker on it, you're really only going to get about 70% of your on torque to take that off. So what we have here are a very succinct set of core thread locking products. You could see the screenshot there of all the different types of thread lockers. We even have more than these. But when you think about thread lockers, there's a reason why we have a color for them. A blue thread locker represents medium strength. That would be the 243. If you guys are familiar with our traditional 242 medium strength thread locker, what you'll know about that is that the same hand tools used to put them on, the same tools you use to take them off. No heats required, no special equipment's required, okay? 263 is now the next generation of the 262. Again, that's a red product. So if you see red thread locker, I want everyone to think of a stop sign, okay? Stop, because that particular thread locker is a high strength thread locker and that will require heat in order to remove it. So if that assembly cannot exceed 500 degrees for 5 minutes, then you may want to stay away from using a red thread locker for that particular application. The last one there is the 290. It says post-assembly. We're going to go into a little bit more detail about the characteristics of that one, but that particular thread locker is used after you've already assembled a nut and a bolt. So maybe you have an assembly and you realize after the fact that they're vibrating loose or that they're getting very corroded, and you don't want to take them all apart in order to apply some thread locker. With the 290, you can apply it after they've already been assembled, and it will wick its way up in between the threads. It's a very, it's a great versatile product in that manner there. And the last thing I just want to bring to your attention is, when Josh spoke about how these products cure, how they go from a liquid to a solid, is you want the absence of air and the presence of an active metal. Not all metal is active. we typically would have a primer that you could prime on that surface, put some copper salts on that surface, and that allows the product to actually cure faster on that surface. Well, our 243 and our 263 are the next generation thread lockers. These are the two most user-friendly thread lockers really on the market because it does not matter anymore what metal you use. These are almost surface insensitive. It's as though the primer is already in the bottle of thread locker. So it'll cure on inactive surfaces as well as on active surfaces. It has a 360-degree temperature rating, and they cut through the surface oils so much better than a standard thread locker. These truly are two most user-friendly thread lockers out there. Now for a blind hole, this is something that we could go over in a personalized training for any customer who wants a personalized training. But if you're applying a thread locker on a blind hole and you only put the thread locker on the bolt, what will happen is as you torque down that bolt into the blind hole, all that trapped air wants out. And what it'll do is it'll force the thread locker back up through the threads, and you will not have enough thread locker on the threads itself. So it will not unitize the assembly. So the proper steps are put some product into the hole first, let it cascade down one side of the flanks of the threads. Now put a drop or two at the leading edge of the bolt, and now when you torque it down, you will unitize that whole assembly.
Awesome, thank you, Rich. And I'll talk a little bit about our 290 wicking grade. So our 290, which we talked about, the wicking grade thread locker, is a similar strength to our 243, the most common blue bottle, and it's used for post assembly. So if you've got something like Rich touched on, if you can't take it apart, if you don't have the ability to take it off to apply thread locker on there, you can actually use it and you can put it on the outside and it will wick into that area. So I got a quick video that'll kind of show you how that's done. So just a little example of how the product works. It uses capillary action, which is the adhesion of liquid to the walls of a vessel, in this case the bolt, causing an upward force on the liquid at the edges. So as you'll see, the liquid, the 290, is actually climbing the bolt. It's going anti-gravity, it's going up, and that's through the capillary action. So super handy, again, if you don't have the ability to remove the bolt to apply liquid thread locker. Sorry. So we also have our sticks, the stick thread lockers. We'll just touch on this. The benefit is it's easy to use, right? You just apply it. Comes in like a chapstick tube that you just turn as you need more material. I assure you it is not chapstick. Do not use it on lips. It's less messy, right? You're not going to get any dripping, especially in a plant where you can't have a drop or two on the floor. If you're using a red thread locker, a drop on the floor could look very similar to blood. So to prevent that, you've got our sticks, pocket friendly, and easy to use, convenient to use in any direction. So especially if you got overhead applications and you don't want to squirt a liquid thread locker over your head and possibly drip it down onto your face, the sticks are super handy. So now we're going to talk a little about thread sealing. So why do pipe threads leak? I'm going to open it up to you guys again in the chat, Mark, if you let me know if we get any responses, but why do pipe threads leak?
One answer is because there's air.
Exactly, perfect. All right, there's airspace in there, which is the culprit for vibrational loosening, and also when we're talking about pipes and leaks, air is the culprit. So exactly what you said, there's not 100% metal to metal contact. And the reason for that is it's cheaper, and also it could be because of temperature changes, hot to cold, cold to hot, could cause for expansion and contracting in metal, vibration shock, kind of like what we talked about with the nuts and bolts, or inefficient sealants. You know, we're not always using the correct sealants. So what do you guys use to prevent these leaks right now? What kind of products are you using to prevent pipe threaded leaks? I'll open it up to the chat again.
So one answer was pipe dope.
Pipe dope, big one, yep. Any others? There's another big one out there. Everybody's got some, I'm sure.
I don't know, I think we stumped them.
Okay, the other one I would say, so pipe dope, thank you. That's a big one. That's a main one that we see. And the other one is Teflon tape, right? We're using that to seal the threads. So there's pros and cons to them, right? Pipe dope, Teflon tape, they're cheap, readily available, you know, relatively easy to use. And it's always on hand. We always have it, right? Teflon tape, there's Teflon tape everywhere. In every toolbox, somebody's got Teflon tape. But one of the cons is, you know, well, pipe dope as it dries, it can crack, right? As the solvents evaporate out, it dries out and it can crack, which leads to more air paths, which would again lead to leaks. Teflon tape, technically it's a lubricant, right? You think of Teflon like on your pots and pans at home. It's more to prevent sticking. So it's a great lubricant, which is why you use it in between the threads so that you can get something onto, you know, you can thread an assembly a little bit easier, but it doesn't actually seal, even though we use it as a sealant. It fills some space, but I'm sure you guys have all seen, it can break, it can rip, right? You have to, if you over tighten it or back it off, you'll see rips like you see down here in the corner. So while they're great and they have their purposes, you just got to be aware of the considerations and the problems that can come along with those. So we're gonna watch another video, and it's gonna be strange watching my lips move, and I'm gonna try to talk through it kind of like Rich did. But some of the products, so we have products that can kind of help alleviate that inventory of the stuff that you have that, you know, that you're using as a sealant, but maybe not doing the job. So our 567 contains PTFE, which is what Teflon tape is made of. So it gives it that lubricity, so you can actually get the threads together. It's perfect for air leaks, and it comes with this great ribbon tip. So you see it has that flat edge tip, which is perfect for really getting the material into the threads. And you want to do that. You don't want it to just sit on the threads, because kind of like a blind hole, if you just put on the threads, material is just going to kind of push out as you're tightening and getting the metal to metal. So you dig it into the thread, so you're really filling in all the air space and preventing any air leaks. And one of the things you talk about with Teflon tape is you don't really have a lot of maneuverability. You can't really adjust it once you get it on. You over tighten it and you got to back it off. Well, that's ripped. Got to start all over again. Getting it off is a pain in the butt. With our liquid 567, you have about 15 minutes before it you know, kind of comes to an initial cure. So within that 15 minutes, you can adjust it and you can maneuver it, so you're not going to worry about ripping it. And then once you know, so right away you get it on, and you got, within seconds, once you pressurize it, you've got about 500 to 600 PSI worth of resistance. So that 500 to 600 will go up to about 1,000 within that 15-minute time frame. And with a full cure, which is 24 hours for almost all of our products, you get about 10,000 PSI worth of resistance. So also comes in a stick form, 561. If you're dealing with hydraulic or pneumatic lines, we have our 5452 in that little red bottle that you just saw. That does not have PTFE in it, because PTFE can clog those lines. So if you're dealing with those, you want to use 5452. So it's just a little bit of a recap. 567 is a great general purpose thread sealant, and it's great on stainless steel, aluminum. Like we said, like Rich mentioned about the primer, this has a primer already kind of built into it. So it's great on those inactive metals. And now I'm going to turn it back over to Rich, who's going to go over retaining compounds.
Awesome, Josh. Thanks again, guys. So now we're transitioning from threaded assemblies, right? No longer talking about thread lockers or thread sealants. Now we're talking about what we'd call a cylindrical assembly, essentially bearing on a shaft, a gear, a sprocket. And there's a lot of traditional ways of holding these assemblies together. You know, you have interference fits, you know, shrink fits, press fits, keyway splines, set screws, and things of that nature. You go to the next slide, Josh. Traditional ways, you know, set screws and pins. The press fit and probably the shrink fit are probably the two more common ones that I see, but we're all dealing with these types of assemblies, and you're all dealing with these types of assemblies in your plants, and they all have some added benefits as well as some limitations as well. You want to go to the next slide? So what the retaining compound is trying to accomplish, just like it was, you know, with the thread locker and thread sealing, is we're trying to fill in an airspace. How much metal-to-metal contact do you think you're actually generating in an interference fit or with an interference fit? You know, believe it or not, you're dealing with probably 20 to 40% metal-to-metal contact. The rest of that area is filled in with nothing but air, okay? So what these retaining compounds are trying to accomplish is they're trying to displace that air and unitize that assembly. So these are three very common retaining compounds. The 609 general purpose retaining compound, think of it as a medium strength thread locker, okay? Gaps of up to 5 thousandths, but that's radial gap, diametric about 9 thousandths. If you want to go to the 680, that's for slip fits. That's a very high strength product there. And the 660, that's a great one. We're going to talk about that in a couple slides, but that's a high viscosity retaining compound. So I'm back in my bubble here doing a retaining demo for everyone here. Now, what I'm going to show you here is a small pin and collar to simulate, say, a bearing on a shaft. And something that size, an FN4 press fit would generate about 2,000 PSI in shear. So if you use the press fit to put something that size together, you get about 2,000 PSI. And what you're seeing there, that little red line there in between, that's the open air space. So that's where oxygen could get trapped, moisture could get trapped. And over the course of the operation, you got metal rubbing against metal, and with the added oxygen in there, that's the recipe for fretting corrosion. So now your 30% metal-to-metal contact is 28%, 25%, until that friction alone, that interference alone, isn't enough to keep it on a shaft, and that's why a bearing would want to prematurely come off a shaft. So what I'm showing you now is that pin and collar, and as you can see, as I'm moving it back and forth, it is a slip fit. Okay. So what I've done, that's just to show you that's a slip fit. I put some of our 638 retaining compound on a similar assembly. I gave it less than a day to cure, and I'm going to try to take it off with a gauge to actually measure how much PSI and shear it is. And as I'm turning this, I want you to see that gauge go up, and I pause a little bit. When I pause, that's at 2,000 PSI right there. So that's what an interference fit, an FN4 would give you. And then it goes up just about halfway up there. So as it approaches 3,000 PSI, it finally breaks. So the point of the demo video is on a slip fit pin and collar, you could generate close to 3,000 PSI in shear. When on an FN4 press fit, you get closer to 2,000 PSI. And the FN4 press fit is not filling in all that airspace to seal out outside moisture. And that's really the benefit of using a retaining compound. It unitizes the assembly. It evenly distributes the stresses and loads on that assembly. So you get more life out of it, and you don't have to worry about corrosion impacting it. And the last one here for the 660, whenever you have a large gap that you want to kind of prevent that chattering from happening, maybe it's in a keyway or maybe it's in an application right here, we have a high viscosity retaining compound called 660 quick metal, and it'll cure through a 20,000 gap. So it's a very versatile product, and there's plenty of areas in your facility where you can utilize that. And over on the right, you see how it's used to kind of reinforce a keyway. Thanks, Josh.
Awesome. Thanks, Rich. So I'm going to take over and we're going to go over gasketing quickly.
Josh,
So,
actually, guys,
yes.
before you jump, I was a little late in getting a question. There's a question a little ways back, Rich. It says, how many drops are appropriate based on the size of the application of the threads and sizes?
Okay, that's a great question. We would go over a lot of the best practices with more time and in-person stuff at the customer location, but the rule of thumb is this, guys. You want to cover the amount of threads the width of the nut. So, for example, on a 3/8 fastener, you want to cover 3 to 4 thread widths, because if you took that nut and aligned it up to the fastener, that's about 3 or 4 thread widths. So if you have larger fasteners, just take the nut, put it up against the bolt, okay, and see how wide the nut is. That's how many thread. That's how much space you have to apply the thread locker. You don't need to drown it in thread locker. You just want to cover up those threads, okay? And also apply the product where you want the nut to end up. Don't put it at the leading edge, because as you're torquing down that nut, you'll lose some in the travels, and there may not be enough to fill in the space in between the threads. I hope that answers that question.
Yeah, hopefully it does. Great, thanks.
Perfect. Thanks, Rich. Thanks, Mark. So unless there's any other questions, we'll go into gasketing. So the functions of a gasket, right? Let me get back over to this. Here we go. All right, so the functions of a gasket is to keep fluid or gas, liquid, vapor where it belongs by joining two surfaces and creating and maintaining a seal between them. So some examples of gaskets you guys use, I know ones that we see very commonly are, rubber. It's a big one. You can have cork, paper. There's a ton of different gaskets, which all serve a purpose, but you get a lot of inventory of those gaskets. So what's the perfect gasket? No gasket is the perfect gasket, but it's extremely expensive and costly to machine a fit or flanges to be a perfect fit, right? The only places that you would see that can afford to do that and charge hefty amounts for being able to make those perfect gaskets are NASA, right? And anything in aerospace, typically you've seen perfect gaskets, or Rolls-Royce, they typically use, their machines are creating perfect gaskets. So I'm gonna do a quick little demo here. Just gonna turn off the volume so I don't hear myself. But I'm gonna do an example, show an example of a couple of flanges. These are glass, just to show that one is a rigid and one's flat. And when you join them together, and one is a rigid one, again, not perfect gasket, so one's gonna have some imperfections. There's gonna be peaks and valleys, which again leaves airspace and a path for fluid or gas to leak out of. So the sponge is gonna represent our gasket. And what I'm trying to show you here is that as you tighten the flanges together, in some cases you may tighten one area too much and gets off torquing, leaving again paths for air or liquid to leak out of another side. If you tighten the overall both flanges too much, so you could get bowing or bending, so that leads to a misshapen gasket. You could also get extrusion, right? If it's squeezing together too hard and the gasket is coming out one side or getting pinched too hard, it's extruding out, which could again lead to cracks and more air or fluid space. And one of the big ones is if you tighten it too much and after you have to keep tightening it, you get compression set, which similar to like your couch on a carpet, right? After something is sitting on a surface for so long or pushing it down for so long, and you move that it becomes set like that. So we're going to take a look at our 518. This is our liquid gasket, which helps to eliminate, again, some of that excess inventory on all shapes and sizes, because with a liquid a gasket maker, you can fit to form, right? So depending on what size or whatever surface it is, you can kind of make the gasket to whatever shape, since it's in a liquid form. So in this case, we're just going to do a triangle, and as you join the flanges together and you've got the gasket maker in there, you're going to see peaks and valleys. Again, the surfaces are imperfect, the flanges are imperfect, so on the high areas you're going to need less material, and on the lower areas where there's a bigger gap, you're going to need more material. So using our 518 is going to help to fill in those areas appropriately, as opposed to a one-size-fits-all approach with your traditional gaskets. So quickly, just going to peruse over the tools. So you've got our 518 is what I showed you there. And then we've got a couple different options, again, for gasket eliminators, just to alleviate some of that inventory you have. Also comes in the stick version.
Josh, I see a question. Are there
Sure.
temperature limitations, or what are the limitations of those gasketing products?
Great question. So there are temperature limitations. Let's see. On the 518, each one is a little bit different. Rich or Matt, do you guys know offhand what the 518?
Yeah. Typically with the anaerobic gaskets, the 518, 510, 515 that Josh was describing, you're looking at about 300 F as a temperature limitation, as well as about the 50 thousandths of a gap fill limitation. So if you are within those parameters, about 300 F and about 50 thousandths of a gap fill, these anaerobic gasket makers are great. They're perfect for rigid flanges. If you find that you need a higher temperature resistance, say 500 F, or maybe even up to a 1/4 inch of your gap fill, that's when you want to look at using some RTV silicones. And we have a plethora of them to help out there.
Thanks, Rich.
Yep.
Awesome. Great question. Thanks for that. So unless there's any other ones on gasketing, I'm just going to touch on our concrete repair products. And the main one that you guys may see as being beneficial, especially coming back from COVID. And as we get into the colder temperature and the winter months, you start seeing some cracks and some concrete damage. Our 9410 Magnacrete, great product. It's got a great competitive advantage, as it cures in a 1 hour. It's got a 1 hour functional cure. So it's drivable with forklifts within an hour. And it dries to a 13,000 PSI compressive strength, which is typically stronger than the original concrete is, 3 times stronger. So it's a 2-component. It's not just mixed with water. It's got the additive in it that you need to mix with it. You can kind of make it to however thick or thin you want based on how much of the aggregate and additive you use together. It also comes with winter or summer additives, depending on how hot or cold out it is. If it's really hot, it's going to turn over real quick. So we have summer additives to kind of slow that process down if you need that. Same with the winter to speed it up. So just, we've kind of touched on all the major, core modules of Loctite and what we have to offer. There are several others, metal rebuilding, shaft repair, belt repair, anti-seize. We touch on concrete repair, anti-slip coatings, wear prevention, bonding, sealing, whether it's instant adhesives, surface protection, rust prevention, and grouting. All products that we have. If you'd like any other information on those products, feel free to reach out to your A&M rep or one of us, and we'd be happy to get you more information on any of those. So I'm going to talk quickly about documenting cost savings, right? So it's a big part of what you guys are trying to do for your facilities. So just to give you an overview, Loctite has seen over $26 million in customer approved cost savings in 2019, and over 10 million in thread locking cost savings alone in that time. Through air leak surveys, we did over 80 of them in 2019 with 2.5 million in uncovered air leak dollars, right? Those air leaks can be expensive. and some more numbers there just to kind of give you an idea. So we'll go over an example of a documented cost savings. In this particular Pepsi plant, there was keyway wallowing happening and fasteners loosening on vents, on the vent tubes and filling valves, which was creating downtime. And based on the information we got from the customer, the cost of that downtime was, once we eliminated that, using Loctite 660 was a product that we came up with as a solution. Once we were able to do that, we eliminated a lot of that downtime and gave them a cost savings of $120,000. And with the fasteners loosening, we were able to switch to a thread locker that would prevent that fastener from loosening. That's additional $30,000 in cost savings. So for this particular example, there was over $150,000 in cost savings for the Pepsi facility. So if you got facilities like these, we'd be happy to come out and help you document some of these cost savings. Another way we can document cost savings or help you find some cost savings are through our air leak surveys. In this example, there was a plant running 24/365, identified 204 leaks, trained the staff on how to use our Loctite products, thread sealants and flange sealants to address the issues. And once they corrected those leaks, they were able to provide over $113,000 in potential annual savings, and that will compound each year, right? So, we'll identify those areas. I'll give you an example. Here's an air leak survey example. What it'll look like as we go through, we come in, we identify the leaks, we tag them, we recommend products, for those specific leaks, and based on the decibels that we read from that area of the leak, and your kilowatt hours cost and how many days and hours per day they're running, we can identify the exact cost of that leak. So in this particular example, the annual cost of all the leaks identified was $16,000. Typically, we're seeing anywhere over, it's almost in every case, over $10,000. So if it's something that interests you and you'd like more information on, again, please reach out. We'll give you a great breakdown, a report at the end it'll give you these charts and show you what the biggest cost of those leaks are and how it breaks down, so that you can kind of hit the big ones first if that's what you're looking to do, and address the most costly ones in a timely manner.
So we do have a question just to clarify that.
Sure.
So the Loctite folks go out into the field and actually do that survey themselves, and is there a fee for that?
Yes, so there is a fee, and your A&M rep can go over that fee with you. And it is typically anywhere, depending on the size of the facility, it's a day or 2-day process typically. But yes, that is something that the Loctite rep will come out with the A&M rep, with your local A&M rep, and we'd like to walk through the facility either beforehand or definitely, during the survey, have somebody walking us around to help us identify the areas, so that when we do that report at the end, we can say, okay, in this area, on this line, and have kind of specifics to make it easier for you guys when you get that final report. But yes, that is a service that we offer, and A&M can give you that price. Typically, it's in the range of, I want to say about $3,000 per day. But again, we're typically seeing a minimum of $10,000 in annual cost savings, if not well more than that. So hope that answers the question. So again, some resources for you guys. We can create line cards. Some A&M may have a few of these. Some of the reps may have them. We can create these specifically for you guys, for end users. If there's certain products you want to, that we went over today that you'd like to keep those numbers on hand so that you can potentially inquire with A&M or order those in the future, let us know. We'd be happy to make those for you. We also have trainings available. Again, we will send this out. Mark will forward this out to you after this webinar concludes today, with some links on how you can do some trainings online if you're interested. We've got them through Loctite or on YouTube. So would love to help you guys out if you're interested in taking those. So that's really all I got. I got a quick screenshot here. Again, this will get sent out to you guys so you have our contact information, and just so you know who the local reps are. But other than that, Mark, I'll turn it back over to you for questions. If there's any other questions that anybody has, I'd be happy to answer them.
Thank you very much. Guys, I appreciate you taking the time. And there's time here at the end for any other questions. If anybody has any questions, we'll give it another minute. Again, as Josh said, we will be sending out both the PowerPoint as well as the video, a link to the video, so you can watch this later or share it with other coworkers if it's something that you want to share. And just the other note here, the next one of these sessions is coming up in 2 weeks. Best practices for using abrasives for the fabrication industry with 3M. So right now, I don't see any additional questions. I think we answered them as we went. Again, I want to thank Josh and Matt and Rich, all from Henkel Loctite, who shared their expertise with us today. And I thank everybody for attending. And with that, we'll say have a great day.
Awesome. Thanks again,
guys.
everybody. Thank you, Mark, and everybody at A&M. We really appreciate it.
All right, very good.
Have a great day, guys.